Well, which one's linear, which one's quadratic? If you look at a table, you've got to find the rate of change. So you got to find how quickly these outputs are changing. From 4 to a 7, that increased by 3. From 7 to a 16, what did that increase by? 9. And then from 16 to a 31, that increased by 15. From a 52, or from a 31 to a 52, that increased by 21. From 52 to 79, is that 27? So if you find the pattern, let's see, from 3 to 6, it went up 6. From 9 to 15, it went up 6. From 15 to 21, it went up 6. From 21 to 27, it went up 6. So this one right here is quadratic. Quadratic because your second change is constant. So quadratics, they increase, and they're increasing at a constant change. Maybe I said that wrong. They're increasing at an increasingly constant rate. Okay, this one is going to be your linear. Your linear is pretty slick. From 4 to a 7, that went up 3. 7 to 10, that went up 3. 10 to 13, up 3. 13 to 16, that went up 3. So this one is increasing. What I said before, this one increases at a constant rate. So your first change is constant. So in detail, what makes a function linear? Function is linear when the increase is a constant rate. And quadratic, this guy, it's increasing, but it's increasing at a increasingly constant rate. So your second change is constant. This is right here probably what you should put. Okay, one of these equations is linear, one of them is quadratic. Which one's which? Describe in great detail what makes a function linear and what makes a function quadratic from the viewpoint of an equation. Okay, linear is if your greatest exponent is 1. So this is how I eyeball and determine really quick that that equation is linear. Quadratic, I know this one is quadratic from just looking at the equation because the biggest exponent is a 2. And so here's what I know. I know if your biggest exponent is 1, it's going to have only one solution. But a quadratic is going to have 2 solutions. So let's solve them. Solve for x. So let's undo the subtract 4. Let's plus 4 plus 4. You got a negative 3x is equal to 24. Divide by negative 3. Divide both sides by negative 3. X is going to equal negative 8. So just one solution. This one, let's solve it. I'm going to anticipate 2 solutions. So my first move is I'm going to get everything on the same side. So I'm going to minus 6. I'm going to minus 6. So I've got this. I've got x squared minus 3x minus 10 is equal to 0. Okay, now in my head I'm trying to think of 2 numbers that are going to multiply and give you a minus 10, add and give you a minus 3. Because if I can express this addition problem, if I can rewrite this as the product of 2 factors, so I'm factoring it. What are the factors of x squared minus 3x minus 10? And it is going to be x minus 5 and x plus 2. Because a minus 5 times 2 is going to be my minus 10, and if I add them, it's going to be a minus 3. So now, I factored it and I wrote it as the product of 2 factors, but my answer is 0. That's sweet. Because I'm multiplying and I'm getting 0, so that must mean I'm multiplying by 0. So x, if I plug in x to here, if I plug a positive 5 in, 5 minus 5 is 0, 0 times that, there is my 0. Or this one, if I plug in a negative 2, that will also give me a 0, and 0 times anything is 0. So there we go. 2 solutions for a quadratic. There they are. only one solution for a linear. What about a graph? Okay, if you're looking at the graph, how do you know what graph is linear and what graph is quadratic? So, going back to your freshman days, m is a -3, or slope, I like to think of it as rise over run. So I'm going to look at it as a fraction, -3 over 1. And your b is a -4. Okay, b is your y-intercept. That's your first dot. So I'm going to go down 4. And then use your rise over your run. You're going to go down 3, right 1 to get a dot, down 3, right 1 to get a dot. Or you're going to go up 3, left 1, up 3, left 1. So your dots, and if you connect them all, you're going to have a straight line. So a linear graph will always be straight. It's going to go forever in both directions and looks somewhat similar to that. The steepness is going to change. Okay, this one, a quadratic. I know it's quadratic because the exponent is 2, and the general shape of a quadratic is totally different than a linear line. So I know the general shape is going to be a parabola. Parabola is going to look something like that, or something like this. And to graph a parabola, you need to determine the values of a, b, and c. A is this, it's the number in front of your x squared. A is 1, b is a -3, and c is -4. So the combination of your a, b, and c determines the shape and size of the parabola. So I'm going to start step number 1. I know this guy is just like this guy. The number all by itself with no variable is always going to be the same in any type of graph. It's going to be your y-intercept. That's your first dot. My first dot's going to be right here, -4. Okay, now from your first dot, I need to know my line of symmetry. So parabolas are symmetric. I got to find that line of symmetry. Okay, the line of symmetry comes from this. It comes from a -b divided by 2 times a. So I'm going to plug in b and a. So it's going to be a -b divided by 2 times a. So it's going to be, what is that? Positive 3/2. Okay, 3/2, it's a fraction, but it's not too bad. 3/2 is going to be between 1 and 2. So I'm going to go over somewhere like right here, somewhere between 1 and 2. And I am going to draw my line of symmetry. Okay, on the final, I'll give you a friendly one. That's going to be an integer, not a rational. So there's my line of symmetry. Now here's what I know. I know they're symmetric, so this dot is going to reflect across here, so it's going to be somewhere like right there. Now all I need to know is the vertex, and if I can find the vertex, we're going to be in good shape. So the vertex, here's what I'm going to do. It's kind of like a table, an XY table. If I plug in for X this 3/2, what is it going to spit out for Y? So your rule is right here. You're going to have to plug 3/2 in right there, and you are going to have to plug 3/2 in right there. So let me erase some stuff. This could be a little stressful because of that dang fraction. So on the final, I'll give you a nice integer, but let's do it. We can do it. So let's plug in 3/2. Okay, 3/2, it's going to be 3/2 squared minus 3 times 3/2 minus 4. So 3/2 squared is 3/2 times 3/2. That's going to be 9/4. A minus 3 times 3/2 is going to be a minus 9/2. And a minus 4. That is awesome. Alright, now, if I have got 9/2 and 9 Well, let's see, I got 9 fourths, 9 halves, and 4 ones. Common denominator is going to be, let's go 9 fourths. Let's change this to fourths. So that's going to be a minus 18 fourths. And if I change this to fourths, it's going to be minus 16 fourths. So 9 fourths minus 18 fourths minus 16 fourths is going to be what? 9 minus 18 minus 16. Minus 25 fourths. Oh, that was kind of ugly. So when I plug in 3 halves, it's going to spit out a minus 25 fourths. Alright. So I'm going to go over 3 halves. So it's going to be on this line. Down 25 fourths. 25 fourths is, what is that? 6 1/4. So I'm going to go down 6 1/4. So just a little bit past 6, not much. And your parabola is going to look something like that. It's going to go through those 2 dots. That's your vertex. That's where it's going to turn around. And we love fractions. Alright, now here's the father of all quadratics, just a simple y equals x squared. So plug 4 numbers in and their opposites. So if I plug 1, 2, 3, 4 and their opposites, -1, -2, -3, -4. So plug them into the function. If I plug 1 in, what's 1 squared? It gives me a 1. What's 2? 2 squared is 4. 3 squared is 9. 4 squared is 16. Okay, now plug their opposites in. -1. -1 squared is a -1 times a -1. Still positive 1. Same with -2. If I plug -2 in, -2 times -2 is positive 4. -3 times -3 is positive 9. And a -4 times -4 is positive 16. So if you graph them, if I go over 1, up 1. Over 2, up 4. Over 3, up 9. Over 4, up 16, that's not going to fit. Now if I go left 1, up 1. Left 2, up 4. Left 3, up 9. Left 4, up 16. Here is your parabola. I know at 0, if I plug in 0, it's going to give me a 0. So I know that's your vertex. That's where it's going to turn around. So your parabola is going to look like this. Okay, now all parabolas are symmetric. But here's the question. Look at the table. Look at the graph. Why are they symmetric? Why are they symmetric? And it has everything to do with your exponent is a 2. Because anytime you square something, you can square a 2. And if I square 2, I'm going to get 2 times 2, that's 4. But you can square a -2 times a -2 and still get the same outcome. So it's kind of like this. If I take this, if I ask you what number squared is 16, there's going to be 2 answers, because I can square, I can do 4 times 4 is going to give you 16, or you can do a -4 times -4 is going to also give you 16. So anytime you're squaring something, it's going to be symmetric, because there could be 2 different outcomes. And I know this is symmetric right across this number right here, right across 0. So 0, 1 to the right of 0 and 1 to the left of 0 are going to give the same. 2 to the right of 0, 2 to the left of 0 are going to give the same. So if my vertex was right here, all the way over here at 5 and down 6, I know that the center is on 5. So 1 to the right of 5 and 1 to the left of 5 are going to be the same. 2 to the right of 5 and 2 to the left of 5 are going to be the same. So you got to find your center. In this case is 0. So 1 above 0 and 1 below 0 give you the same answer. 2 above 0, 2 below 0 give you the same answer. Alright, here we go. Now let's find the solutions of this quadratic equation. Use the skill of the zero product property. The zero product property is if I can write a product, a multiplication problem that equals 0. So let's get everything on the same side. Let's minus 10 minus 10. You got x squared minus 5x minus 14 is 0. Okay, now the zero product property says if I can rewrite that as the product of two factors, I can use a little bit of logic, and I can. I know that it's going to be the product of x minus 7 and the product of x plus 5. That is the same thing as x squared minus 5x minus 14. So what I did is transformed this trinomial into the product of two binomials, times them together, my answer is 0. The only way I can get 0 by multiplication is if I multiply by 0. So my logic says one of these guys has to be 0. Either this group is 0 or this group is 0. I don't know which one. What would it take to make this group be 0? It would take x equaling a positive 7. What would it take for this group to be 0? X would have to equal a negative 5. Alright, this guy. Okay, completing the square. So, maybe I gotta back up. Why would you want to use this? Because that's going to be kind of a big question. Why would you want to use this? You want to use it when your answers are from the integers. They're going to be integers. They're easy to work with. Anytime your answers are integers, so in my head I knew that I could find two numbers that times give you negative 14, add and give you negative 5. And it was going to be negative 7. Oh, this is not 5. I'm an idiot. I think it's supposed to be 2, not 5. Alright, so plus 2. I'm glad I came back here. So it's got to be a minus 7 and a plus 2. Because when I multiply minus 7 and 2, that's going to give me minus 14. When I add them, it gives me minus 5. So I'm sorry about that. Should be a positive 7 or a minus 2. Okay, now this one, completing the square. So if you come across this trinomial, and we try the same thing, so let's get everything on the same side. If I plus 8 and plus 8, I've got this. I've got x squared minus 4x minus 46 equals 0. Okay, now what I'm trying to do is 46. What's going to multiply and give you 46, add and give you 4? 46 is 1 and 46, 2 and 23. 4 is not going to go in there. 5 is not. 6, 7, 8. I think that's it. All I can choose from is 1 and a 46 and a 2 and a 23. Can I add or subtract those? So I got a minus 46. Can I add or subtract them to get a minus 4? With integers, no. But with irrationals or rationals, probably yes. So I'm going to ditch that zero product property, and here's what I'm going to use. I'm going to use completing the square. Okay, completing the square is useful. Why? Because my answers don't come from the integers. Alright, so they're going to come from another set of numbers. So I am going to ditch this minus 46. I'm going to plus 46 here. I'm going to plus 46 here. I got x squared minus 4x equals 46. I'm moving it to the other side. Okay, now I'm going to think of my own number. If I could choose any number I want, what would I choose? And I would choose something that would complete the square, that would make this guy a perfect square. Whatever I add to the left, I've got to add to the right. So here's what you do. You take this middle term, you take your b, you cut it in half. So what is going to add itself and give you negative 4? It's going to be a negative 2 and a negative 2. And then you square it. What is a negative 2 times negative 2? It is a positive 4. So positive 4 is the number I wish I had. So I'm going to put a positive 4 there. I'm going to put a positive 4 there. Okay, now this is a perfect square. I just created a perfect square. I'm going to factor it. And it is going to be x minus 2 times x minus 2. But I'm just going to write that as x minus 2 squared. On the other side I got 50. And now I'm just going to use algebra to undo it. So I'm going to undo the square, undo the square. I've just got x minus 2 on the left. On the right, anytime you square root a number, here's where your two solutions come from. It's going to be either the plus square root of 50 or the minus square root of 50. Okay, square root of 50 kind of rings out at me. Square root of 50 is the same as square root of 25 times the square root of 2. And I know square root of 25 is 5. So here's what I'm going to do. I'm going to swap out square root of 50 for plus or minus 5 times the square root of 2. X minus 2 equals plus or minus 5 times the square root of 2. So just undo the minus 2. Add 2 to both sides. Your final answer is x equals 2 plus or minus 5 times the square root of 2. So your answers do not come from the integers, they come from the irrationals. Now use this equation to demonstrate the skill of the quadratic formula. Okay, the quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, why in the world would you ever want to use the quadratic formula? I would want to use it because this sucker does not start with 1. I mean, this looks kind of beastly. I'm going to go 8n squared minus 8n plus 11 equals 0. I'm going to get everything on the same side. Okay, this is my a right here. This is my b. And this is my c. So, since that's too intimidating to factor or complete the square, I'm going to use the quadratic formula. So here we go. X equals a negative b. So it's going to be a negative 8 plus or minus the square root of b squared. Negative 8 times negative 8 is 64. Minus 4 times a times c all over 2 times a. Alright, so now let's just do the arithmetic. From here on out, it's really just calculator. That's going to be plus 8 plus or minus the square root. Okay, 64 minus 4 times 8 times 11 is going to be minus 288. Okay, on bottom, it's going to be 16. And I know a red flag jumps out at me. I'm going to be in the imaginaries because the square root of a negative, that is going to be an imaginary. So here we go. I'm going to start to go sideways. I'm going to go 8 plus or minus square root of a negative 1 times square root of 288 all divided by 16. Okay, the 288 kind of stresses me out. So the square root of 288, I think we can simplify that. So 288, if I divide it by 16, 16 times 18 is 288. There's got to be something else. 16 and 18. So if I go all the way down to the prime factors, 16 is going to be a 4 and a 4. That's going to be a 2 and a 2. That's going to be a 2 and a 2. 18 is a 9 and a 6. 9 is a 3 and a 3. 6 is a 2 and a 3. Here's all my prime factors. So I'm going to swap out 288 for how many of these 2's? 1, 2, 3, 4. 2 to the 5th. And 3 squared. Okay, now how many can I pull out? If it's square root, how many 2's are there in 5? So I'm going to pull out 2 2's. There's going to be 1 left over. And I'm going to pull out, how many 2's are there in 2? There's 1. I'm going to pull out a 3. So 2 squared is 4. 4 times 3 is 12. So we're going to get 12 times the square root of 2. Oh. Okay, that kind of is this looks a lot easier, because 12, I know that the square root of 288, I should have just done this. That's the square root of 144 times the square root of 2, because 144 doubled is 288, and then you could just go straight here. Square root of 144 is 12, so that would have been easier. Alright, so here we go. We got this. We've got 8 plus or minus. Okay, that square root of negative 1 is I. So it's going to be 12I times the square root of 2 all over 16. Then you stare at it and you ask yourself, can I simplify that fraction? Does 8, 12, and 16 have a common factor? You can divide them all by 4. So if you divide them all by 4, your final answer is going to be 2 plus or minus 3I times the square root of 2 all over 4. Okay, that was beastly. So that would have been a nightmare to do any other way. Quadratic formula is probably the only way we could sanely find solutions. Number 8. Okay, use this one to demonstrate the skill of the square root property. Okay, the square root property is awesome when you are missing this. If you only have your x squared and your constant, then the square root property is going to be definitely the way to go. So anytime you're missing this middle term, the bx, the best thing to do is just undo it. So you got to undo the minus 6. So I'm going to plus 6 plus 6. So I'm going to have 4x squared equals a minus 32. And I'm going to undo the times by 4, divide by 4, divide by 4. X squared equals minus 8. Undo the square root, undo the square root. It's going to be x equals plus or minus square root of negative 8. Okay, I know I'm in the imaginaries. That does not exist in our real world. But in the imaginaries it does. X equals plus or minus square root of negative 1 times square root of 8. So x equals plus or minus I. And I know square root of 8 is square root of 4 times square root of 2. So it's going to be 2 times the square root of 2. So your best answer is going to be x equals plus or minus 2I times the square root of 2. Okay, again, the reasoning behind it, the logic, why would you want to do it, is because I'm missing this middle term. So I'm missing an x. So the algebra is pretty slick to do when you're missing the x. Number 9. Let's go backwards. What if I give you the solutions? Can you write a quadratic equation? So let's do A. If you know the answer is 7 and a negative 2, you got to totally work backwards. X equals 7 or a negative 2. So you got to remember this. You're plugging in a 7 or you're plugging in a negative 2. So 7 plus or minus what is going to give you the 0. So 7 take away 7 gives you the 0. And if you plug in a minus 2 plus 2 gives you the 0. So they're kind of opposites. If this is a positive 7, you're going to do x minus 7. Because if you plug in that positive 7 take away 7, there's your 0. And 0 times anything is 0. So now they want it in standard form. So just work it forward. Go x times x is x squared. X times 2 is 2x. Minus 7 times x is minus 7x. Minus 7 times 2 is minus 14 equals 0. Combine your like terms. X squared minus 5x minus 14 is 0. And to save time, let's just do one of these fractions and call it good. Because this is already getting pretty long. Okay, then one of the fractions. If you've got x equals negative 1, x equals a half. Your fractions, if you understand your fractions, it's pretty cool. But x, so it's going to be x plus 1. That one we can all get. But this one, the fraction, okay, you're going to plug in a half. So, what number times a half is 0? So look at this. If I go 2x minus 1, okay, your fraction is always going to end up, the 1 and the 2, they're going to end up right here. The 1 is always going to, your numerator is going to be this guy, your denominator is going to be the coefficient. So look, think of it. If I drop a half in, what is 2 times 1/2? 2 times a half is 2 halves, or that's just 1. And then what's 1? Take away 1. 1 take away 1 is 0. So there's, your fractions will always follow that pattern no matter what. So now you just multiply it forward. X times 2x is 2x squared. X times a minus 1 is a minus x. 1 times 2x is plus 2x. 1 times a minus 1 is a minus 1. Combine your like terms. 2x squared plus x minus 1 equals 0. Okay, I think I'm going to stop it and then do a part 2.